This is part 2 of modeling with quadratic functions. We are on example 2. All right, so this one says writing an equation using a point and the x-intercepts. So that should key you to which equation we're going to use. All right, a meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. Write a function f that models the temperature over time. What is the coldest temperature? What is the average rate of change in temperature over the interval in which the temperature is decreasing, increasing? Compare the average rates of change. All right, so one thing at a time. First thing is we need to look at our graph and see that we are given 3 points. 2 of them are x-intercepts, so we know that's going to be our p and our q. And then we have another point that's just an x and a y value. So let's start with our intercept form. Okay, so if you remember, we're going to have y equals a times x minus p times x minus q. All right, and again, we know that we have p and q. So p, we can say is 4. And Q is 24. Then we also have another point, 0, 9.6, and we can just say that's our x and our y value. So we have 0, and this is an x and a y. All right, so for y, we're going to plug in 9.6. A is our variable. For x, we're going to plug in 0 for both x's. P is 4. And then x again is 0. And q is 24. Now, we can simplify that to find a. That's what we want to do. Simplify to find a. So we're going to have 9.6 equals, and then we're multiplying here. 0 minus 4 is negative 4. 0 minus 24 is negative 24. So I think this is 96, but let's double check my math here. All right, so let's see. Negative 4 times negative 24, positive 96. Okay, so we've got 96 times a, and then divide by 96. So a equals, what is that, 0.1? Let's see, 9.6 divided by 96. 0.1. So a is 0.1 or 0.1. All right, once you have a, then you can write your function. So we have y equals 0.1 times x minus 4 and times x minus 24. All right, so if you wanted to write this in a different form, you could, but it's fine to leave it like this. All right, now let's look and see what the question is that we have to answer. So A part says, write a function f that models the temperature over time. What is the coldest temperature? So we're trying to find this point here. So what we can do is find the average of the x-intercepts, and that's going to give us the x value of the vertex. So if we do 4 plus 24, we've got 4 plus 24, that's 28. So half of 28 is 14. So what we need to do is plug in 14. And we can find the y value that goes with the x value of 14. All right, so we're going to have y equals 0.1. And then 14 minus 4 is 10. 14 minus 24 is what? Negative 10. So we've got 0.1 times 10. That's just going to be 1, but then we got to multiply by -10. I'm thinking it's going to be -10. Yes, -10. All right, so y equals -10. So our vertex is 14, -10. That's our vertex. So we know that the coldest, what is the coldest temperature? So it says how hours after midnight is your x, that's your hours, and your temperature is your y value. So -10 degrees. So this one's going to be -10 degrees, and that's in Celsius. All right, B part says, what is the average rate of change in temperature over the interval in which the temperature is decreasing and increasing? And then compare the average rate of change. All right, so we know that the vertex is going to be 14, -10. All right, I'm going to write that on the graph because I need a little bit more space here. So I'm going to erase some of this to give me some space to work. All right, so the average rate of change. So when it's decreasing. So the average rate of change when it's decreasing when it's going down. So from 0 and 9.6 down to the vertex, which is 14, -10. It is decreasing over that interval. So see here, you can see it is decreasing from here down to the vertex. Decreasing, it's going downhill from left to right. All right, so what I need to do is average rate of change is similar to the slope formula. So I'm going to do y minus y over x minus x. So I'm going to do -10 minus 9.6 over 14 minus 0. So I've got -19.6 negative 19.6 divided by 14. And that's going to give us an average rate of change of 1.4, -1.4. So that's our first average rate of change. And that's the average rate of change where it's decreasing. So let's do the same thing, average rate of change for when it's increasing. So where is it increasing? It's increasing from the vertex up to this other x-intercept here. So we're going to use 14, -10, and we're going to use 24, 0. We're going to do the same thing. Y minus y over x minus x. And again, we did this in Algebra 1, so I know I'm going through this kind of quickly, but this should be hopefully a review. So we're going to have 10 divided by 24 minus 14 is also 10, so that's just going to be 10 divided by 10, which is 1. All right, so we found the average rate of change when it was decreasing and when it was increasing. Now it says to compare the average rate of change. All right, in order to compare these, we have to think about this one's going downhill and this one's going uphill. So one's decreasing, one's increasing. But to compare them, let's think about the average rate of change as like an absolute value, which means what is the average rate of change, not thinking about whether it's going to be positive or negative. So because the absolute value of -1.4 would actually be an average rate of change of 1.4, that is greater than absolute value of 1. So because the average rate of change is greater at 1.4, even though it's a negative number, the average rate of change for the temperature would be decreasing is greater than the average rate of change for when it's increasing. All right, so that's what we have to look at. Let's see, you can write that as the absolute value of 1.4 is greater than the absolute value of 1. So because this is greater than this, that shows you that there is a greater change in the temperature drop over these hours here from like, what is it, midnight to whatever time. And then the increase, it does increase, but it increases a little bit more slowly with an average rate of change of 1.